This is section 2.3. This is part 4. For this type of problem, we have decimals involved. The directions might tell you to clear the decimals before you work the equation. I strongly suggest you don't worry about that. You have access to calculators. If you didn't, it would make a lot of sense to try to get rid of the decimals before you do anything, but since you have calculators, just use them, okay? Nothing changes about your arithmetic or the way that algebra works just because the number is a decimal instead of a whole number. This 1.00 is just 1, so that is just x. 1x plus. Ask yourself, if you get confused, what would you do if this were a 5 instead of a 0.05? I would distribute the 5. Well, that's what you're going to do here. This is a distribution. So I do 0.05 times 12, which gives me 0.6. And then that's a 1 right there, a negative 1. So negative, it's going to be negative 0.05 x equal to 0.1 times 63. Now this is a multiplication. It's not a distribution because this one's a distribution because it has a minus sign in the middle. If it has a minus or a plus, it's a distribution. If it's just a number, it's simply a multiplication. So 0.1 times 63 is 6.3. Okay. Now I have like terms here and here. So I need to do 1 minus 0.05 to get 0.95x. And then I have plus 0.6 is equal to 6.3. Now I want to get my variable term alone, so I want to get rid of this 0.6 by moving it over here. This is a plus, so I subtract 0.6 from both sides. And that gives me 5.7. So I have 0.95x, that canceled out, equal to 5.7. Now this is 0.95 times x. If this were 95x, I would divide both sides by 95. That doesn't change because it's 0.95 instead. Divide both sides by 0.95. 5.7 divided by 0.95, and you get 6. X equal to 6. And 6 is your answer. Okay. Let's look at this problem. We have some simplifications to get done on both sides. We have distributions. So here I need to distribute a negative 2. And here I need to distribute a negative 3. Negative 2 times positive 2 would be negative 4x. Negative 2 times negative 4 is positive 8. And then I have the minus 8 is equal to negative 3 times 4x would be negative 12x. Negative 3 times positive 4 would be negative 12. And then I have the minus 1. Combine here, combine here. Well, 8 minus 8 is 0. That cancels out. I have negative 4x equal to, there's nothing to combine with the negative 12x, but negative 12 minus 1 is not negative 13. Okay. Now we want to get our x's together on one side and our constant on the other. So I am going to move this 12x over to the left by adding 12x to both sides. Negative 4x plus 12x would be 8x is equal to negative 13 because that canceled. And now to get rid of the 8, we divide both sides by an 8. And we get that x equals negative 13 8ths. That is in lowest terms. That is our solution. Okay, so let's try one more. I'm going to distribute here and see what I end up with. Let's distribute the 9 here and then the 2 here. 9v. 9 times 1 is 9, so plus 9, minus 3v equals 2 times 3v would be 6v, plus 2 times 1 is 2, and then I have minus 8. I have like terms here and here. 9v plus 3v would be 6v plus 9 is equal to, I have like terms here and here. 6v, 2 minus 8 would be minus 6. Okay? Again, you might notice something weird's happening, but you might not. It's okay. We want to get our variables together on the same side. And you know it doesn't really matter which one we do, so let's just say, let's move this one over to here. Well, then I subtract 6v from both sides. And what happens again? Our variables cancel out. And I've got 9 equals negative 6. Now, if you recall, when your variables cancel out, you have something weird. So it's either all real numbers or it's no solution. If you look back, we ended up on this previous problem with something that was true. 18 did equal 18, so we said our answer was all real numbers. But here, is 9 equal to negative 6? No, that's false. So that means there is no solution here. There is absolutely no value that we can plug in for v where this thing would work. It is impossible. No solution. You've also probably seen this symbol before. It has another technical meaning, but we often use it for no solution. And you will see this. It's also called the empty set. If you see that, no solution. And that is the end of section 2.3.